Hey everyone, welcome to yet another episode of my video series on Joshua Bloch's Effective Java, where I go through the items that he has enumerated in this book and expound on them and try and make sense of them. And hopefully, as I do that, you can gain some value from it too. And today, and forgive me for being self-aggrandizing, but I am quite happy because I managed to get through the first 9 items, which is essentially chapter 2, so the first part of the book. And I'm really happy that I didn't do it through. I'm glad that, first of all, I'm really enjoying this. I'm learning a lot. But also, given that this is something I'm new to, expanding and elucidating on programming or just any concept in general, it's something that I think it's a skill that I'm developing on learning to communicate and articulate myself when discussing programming concepts or software engineering concepts, let's say. And obviously, I still don't think I have a really deep understanding of the Java language. Therefore, it's a great feeling to get through the first 9 items or the second chapter, which essentially is the first chapter in this book because the first chapter is the introduction. And today we're going to move on to chapter 3. And as per usual, before I do that, this is not going to change. I've got to always do this proviso in the introduction. So if you've been following along in the series, you can skip this bit to save your time. But without further ado, let us get started with the proviso. Firstly, as I always state, this is not a tutorial, and I certainly am not a teacher or an expert, which is, again, one reason I'm really glad that I managed to persist through the first 9 items, as it is not something that naturally comes to me to be able to, let's say, teach. Firstly, because I too am learning as I go along, trying to make sense of these items and the concepts in the book. So again, sorry, I'm talking too much. The proviso or the caveat is, this is not a tutorial. So please don't treat it like one. I'm pretty sure, in fact, I've already made a few mistakes in the previous items, and I've corrected them and tried to rectify them in the comment section when people have pointed them out. And I'm pretty sure in the remaining, 90 odd items, I'm going to make a lot more mistakes. So firstly, please do point them out. And again, don't take what I say as, let's say, gospel's truth. This is an analogy that I use is blind leading the blind, which is kind of what I feel like I'm doing here. I don't know what the hell I'm doing. And I'm trying to hopefully make things a bit more lucid for you, the viewer, who probably also doesn't know what the hell you're doing. Probably you have a better idea than I do, but still, aren't we all equally lost in this world? Isn't that the ultimate verity? I call this a exploratory disquisition. So it's something I'm trying to collectively make sense of using Stack Overflow, using the community that I'm trying to build around this video series, and since recently, even ChatGPT. I've been asking questions pertaining to this book from ChatGPT, and it has been sublime. It's been extremely helpful. That's great. So again, I think I already made this point. I will inevitably make mistakes. So yeah, please point them out. And given that this is a programming video series, all the code that I use will be up on GitHub. It'll be published on GitHub, not only on my personal repository, but also Joshua Bloch's, let's say, official repository on this book. I'll leave the links down below in the description. And saying all that, let us get started with item number 10, which is obey the general contract when overriding equals. And this item, since we are now in a new chapter, is a part of chapter 3, which is methods common to all objects. So item 10 is undoubtedly the longest item in this book. I think it's probably 15, 20 pages. It's quite long. Therefore, I have no choice but to, I probably could cover the whole item in one really superficial video, but that's not the intent behind this video series. Yeah, isn't that really annoying? I live in a very, very quiet neighborhood, but the moment that I've got to record a video, some son of a bitch. Doesn't matter. Okay, back to this. Where was I? See, I got distracted. Okay, item 10 is quite a long item, and the intent, yeah, that's where I was. The intent behind this video series was always to try and and go as deep as possible into these ideas within what I can manage. Like there's a limit as to what my understanding is. I don't think I can go to like the compiler level and explain the JVM algorithm and whatnot. I'm not that knowledgeable on Java or programming in general. But to my limits, to my current limits, the goal was always to go as deep as possible. So therefore, I'm going to split up this item into multiple parts. For now, I'm thinking 3 parts because it kind of breaks down the item. If you go through it, it kind of has this part where they're all connected, of course, but then one leads to the other, and I think you could break it down into 3 coherent parts, let's say. But also, apart from its length, I really enjoy this item because it does involve some quite interesting computer science. I mean, basic first year uni computer science, but still, it's always a good feeling, at least for me, to revisit some of those concepts like truth tables and logic and all of that we learned in uni. So again, item 10 states, obey the general contract when overriding equals. I apologize, I just realized that since we are starting a new chapter, I looked at the book and I didn't read out the introduction for chapter 10, which is methods common to all objects. So before we get to the item itself, let me read that out. The chapter starts off like this. Although object is a concrete class, it is designed primarily for extension. That's correct. All classes are subclassed from object. All of its non-final methods equals, hashcode, toString, clone, and finalize have explicit general contracts because they are designed to be overridden. It is the responsibility of any class overriding these methods to obey their general contracts. Failure to do so will prevent other classes that depend on the contracts, such as hashmap and hashset, from functioning properly in conjunction with the class. So exactly, as the introduction does suggest, essentially this whole chapter is going to be about this object concrete class, and it's a good segue to this diagram. In fact, this is a let's just call it a skeletal diagram of what all the classes in Java look like. So as you can see, the object is the let me zoom in a bit. The object is the superclass of all the other classes in Java, and they inherit from that. So these methods that Joshua Bloch enumerated, equals, hashcode, toString, clone, and finalize, they're all methods of the object class that we'll be using across all the other classes and even the classes that we create on our own. It provides a really good blueprint. And in this item, we're going to really focus on the equals method and why we should obey the general contract when overriding this equals method by any of these other subclasses that do inherit it from the superclass object. So firstly, just to get some formal definitions out of the way, I always like doing that. I think it's a good way to get a very high level understanding and slowly narrow into a concept. The Oracle docs state, class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. So which is why, again, the advice by Joshua Bloch is to please try and obey the general contract when overriding any of these methods that we inherit. And now, pertaining more to item 10, let's take a look at the equals method because that's what we're going to really discuss in this item. Again, from the Oracle docs, I really like this definition. Actually, it's a very straightforward one and kind of puts it quite coherently. The Oracle docs state, well, the equals method that's how it's defined in the object class, public boolean equals, so it returns a boolean, and then you can pass an object into it as a parameter. It takes an object. The equals method implements, sorry, I should say as a parameter, it takes something of type object. Okay, back to the definition. The equals method implements an equivalence relation or non-null object references. The equals method for class object implements the most discriminating possible equivalence relating Sorry, I'll read that again. The equals method for class object implements the most discriminating possible equivalence relation on objects. That is, for any non-null reference values x and y. This method returns true if and only if x and y refer to the same object. Or in a bit more logic-based sense, x double equals y has the value true. So firstly, it's important to understand this double equals operator. I forget if there's a proper word for it, but we need to firstly explore what this idea of equivalence relation means, because that pertains a lot to this item. But before we get to that, let's firstly try to understand what this double equals operator is. So I got this article from Geeks for Geek, and firstly let me read out the definition, and once we are done with the definition, let's try to make a bit more sense as to how that differs to the equals method that's in the object class. So the definition goes in Geeks for Geeks. We can use the double equals operators for reference comparison, address comparison, and dot equals method for content comparison. In simple words, the double equals checks if both objects point to the same memory location, whereas the equals evaluates to the comparison of values in the objects. So it's a really simple concept. I mean, I could just show it right here. Actually, instead of showing it on my Notion page, let me just open up this article and show it here. So this is quite straightforward. We have two variables, S1 and S2 of type string, and then S1 and S2 will pass true because this string value hello, its memory address is the same. It's immutable, and it'll be in the memory with the same address. So this will really do a memory address comparison. But here with S1 and S3, because firstly, this is an anti-pattern. One should never do this because it's a waste of memory. This new object of string we are creating called hello, this hello for the variable S3, that gets a separate memory address. So then when we do the same comparison, despite the content being the same, it's going to return false because the memory address is different. But that's not the case with using the dot equals method that's in dot equals method. That sounds weird. The equals method that's in the object class. So string obviously is an object. It inherits this method from the object class. And here in both these lines, it's a pure content comparison. So despite S3 and either S1 or S2 having a different memory location, the content is still the same. So that's the comparison that the equals method does. So you got to remember that that's a general contract that we need to respect and we need to follow if we are to override this equals method, that it's the content that we compare. So going back to the definition from the Oracle docs, this term here, equivalence relation, it's actually a mathematical logic concept. So I don't think we're going to get to that really. Firstly, even I myself, because I'm not a logician, I haven't got a good understanding of everything that entails or everything behind the theory behind equivalence relation. But apropos Java, what equivalence relation really means is comparing the content of two objects, which is what we did in this example here. We're comparing the content and not really the reference in memory. And saying all that, let's get to, so I should have mentioned this earlier. In part 1, in this video, which is part 1 of item 10, we're really going to focus on this, when not to override the equals method. And then in the next part, we'll get to the crux of the matter as to when exactly to override it, and then how to follow the general contract or obey the general contract. So firstly, when not to override the equals method. So if we do inherit this method from the superclass object, when is it okay to not override it, despite most times we may have to override it? In the item 10, Joshua Bloch starts off like this. The easiest way to avoid problems is not to override the equals method. in which case each instance of the class is equal only to itself. And then he states, this is the right thing to do if any of the following conditions apply, and he's listed down a few of the conditions. So in this item, we'll go through, in this part of this item, it's getting a bit confusing. In this part, we'll go through those reasons. The first one is if an instance of the class is inherently unique. Now, what does that mean? Firstly, let me read out the definition. He states, don't override the equals method if each instance of the class is inherently unique. This is true for classes such as thread that represent active entities rather than values. The equals implementation provided by object has exactly the right behavior for these classes. So of course the question worth asking is, what is thread? What is the thread class? The thread class, you can go through the docs on Oracle, but it's used to spin up a new thread of work. Simply put, according to the Oracle docs, a thread is a thread of execution in a program. The JVM allows an application to have multiple threads of execution running concurrently. So obviously the thread class is used for concurrency and multi-threading. So why would a instance of a thread be inherently unique? It seems rather obvious, isn't it? Because whenever a new thread is spun up, even if these two threads are spun up from the same state, we're pretty sure that they're not gonna act the same way once they're spun up and they start executing in their computation. The threads in that sense represent a dynamic computation, a dynamic object where it throughout its lifetime it's gonna change. It's not gonna be consistent, and therefore two threads that may again start with the same state will still act completely differently because they'll be doing completely different work. Therefore, it makes no sense to override the equals method that only compares the content of two objects for the thread class, because we know that they're going to be inherently unique. Therefore, if we do compare two thread objects, their content is going to be different. Therefore, it's no use to override it and try and change it, because what the object class has defined in the equals method, that does the job. And if we juxtapose the thread class with something like the string class, where we know the content of the string class is going to be the same, as in not the content of the string class, but if you have two objects like this, we can make this object immutable because we know the content is going to be the same. Therefore, it's no use doing something like this where we recreate a new instance of that class and have a new object. That's, again, as I said, an anti-pattern. So this is a static object in that sense for all intents and purposes, whereas that won't be the case for the thread class. The next reason is to not override the equals method is if a logical equality test in a class is not required. So a warranted question is, what is a logical equality test? Firstly, let's understand what logical equivalence is. And this is kind of what I meant by there's a bit of basic computer science that I find always interesting. So Khan Academy defines logical equivalence as the idea that more than one expression can have the same meaning, but have a different form, often a form that helps make the meaning more clear. So the example on Khan Academy for logical equivalence is if you take these three statements: you cannot go to the park if your sister is awake, or your room is dirty. That's one statement. And the other one is, you can go to the park if your sister is not awake and your room is not dirty. Or even simpler, you can go to the park if your sister is asleep and your room is clean. Now, these three statements, despite having a different structure or different, let's say, content, they are still logically equal. In terms of the meaning we derive from them, there is logical equivalence. But for Java, of course, and I just wanted to read that out because I thought it was quite interesting. By the way, before we get to the Java idea, in the context of Java, I mean, let's take a look at this is like a bi-conditional truth table. So another way of thinking in a bit more formal sense of logical equivalence is if we take, for logical equivalence, if both P and Q are true, then the bi-conditional value is also true. If either one of them is false, it's going to be false. But also, if both of them are false, they still have this logical equivalence. Therefore, it's going to be true. So it's like 1 1 is 1, and then 0 0 is still 1, if that makes sense. But in the context of Java, I just thought that was interesting, and I wanted to go into that. In the context of Java, of course, logical equality compares the content, the content of the object, the data of the object, instead of the values of the memory reference, as we discussed earlier. So let's take a look at a quick demo. Oh, before I get to the demo, let me read out the definition by Joshua Bloch on that point. So again, he says, there's no need to override the equals method if there's no need for the class to provide a logical equality test. For example, the Java util regex pattern class could have overridden equals to check whether two pattern instances represented exactly the same regular expression. But the designers didn't think that clients would need or want this functionality. Correct. This is like the art of object-oriented design. It's important to understand what the context of a API we write will be used. And the designers of this API thought that it's not necessary to override the equals method, because we would never really use the equals method to compare two instances of pattern. And let's take a look at an example. So a quick demo I have here is, let me open that up. So I have this static Boolean method called run regular expression against string, which takes a regex and takes a text of type string. And really what we're doing is we're creating a compile regex of type pattern, a pattern object, and afterwards we're using the matcher, which interprets this pattern. So pattern.compile returns a pattern, a compile pattern, and then matcher interprets what it returns to look for equivalence. So, not for equivalence, sorry, to find that pattern in a given string or a given object of type string. So over here, if I run this, you'll see it returns true, false, false. So the reason for that is because obviously this regex is a regex for an email address, and the first one is an email address. These two don't fulfill the requirements of this regex pattern. And pertaining to our point, the designers made a call that users of this API will never want to compare instances of the pattern class. There's just no reason for it. Therefore, we can leave or to put it in a bit more formal sense, the designers made a call that the users of this API will never require logical equality between instances of the pattern class. Therefore, we can leave the equals method as it is, they thought. And at times like that, there's no requirement to override the equals method. And the other reason, of course, to not override is if the class you're writing and designing already has a superclass and inherits methods from the superclass, and if that superclass has already overridden the equals method appropriately to the subclass, then this wouldn't be an issue. We wouldn't have to again override the overridden equals method. That would be a bit absurd. In fact, we're not going to get to this in this part, but in the next part we're going to discuss the Liskov substitution principle. That is something we should follow when in class hierarchies and in inheritance. Because of that principle, and if we do follow that principle, theoretically there shouldn't be a reason for a subclass to override a equals method of a superclass that's already overridden the equals method of the object class, if that makes sense. So, for instance, before I get to the demo, let's take a look at this. This is a class diagram and I'm not sure what the accuracy of this is because the Java collections framework is huge and it's growing huge. Sound like Trump there. It's huge and it's growing quite a lot. And as you can see here, there are many all the class hierarchies. There are implementations and extensions and inheritance taking place. So the example that Joshua Bloch has given in the item is. So don't override when a superclass has already overridden equals, as I did say. And the superclass behavior is appropriate for this class. And if we do follow that principle, theoretically it should be the list curve substitution principle. For example, most set implementations inherit their equals implementation from abstract set, list implementations from abstract lists, and map implementations from abstract map. And that's why I wanted to have this diagram here, because so if we take a look at set, you can see that the set, or the hash set in this case, is inheriting, the set interface is implemented by the abstract set, as you can see here. And so, sorry, I got a bit confused there. The set interface is implemented by the abstract set, and of course then the concrete class, which is the hash set that is here, extends that abstract set, but also implements the set interface. Not sure why that happens, but why would it extend the abstract set and again implement the set interface if the abstract set has already implemented the set interface? I'm not sure. But in any case, I'm not going to get into the Java collections framework here. But the point being, if the superclass has appropriately done the overriding, there's no requirement for the subclass to do the overriding again. So in the example that I've used, I've just created a few hash sets. I'm just going to write it and show it to you. Whoops. You can see here I'm comparing the first hash set to the second one, and again the first one to the third one. The first two hash sets, so hash set and hash set 2, they both have equivalence in the sense of logical equivalence. So the content of the objects are the same. They both have effective Java. Whereas the third one, hash set 3, has effective TypeScript. And when we compare hash set 3 to hash set 1, it's returning a false. And that's what you expect. So that means a superclass, which was the abstract set class, has done the overriding correctly, and it's following the general contract of the object class equals method. Just on the Java collections framework, as you saw, even I was quite confused. I mean, I really don't know if anyone except probably the designers and, the pantheon of the Java legends have a thorough understanding of the collections framework. It's quite large and extensive. But if you do want to read about it, this is, in fact, not even read about it, but it's just good to bookmark this page and use it as reference. Or these days you could just ask ChatGPT. That life is much easier. Okay, before I go off on a tangent, the other reason to not override the equals method is if you're certain that the equals method will never be invoked. Quite straightforward. That again probably relates to the other point where, as a designer, one has to make that call and see if users of this API will ever really invoke the equals method. So Joshua Bloch states that the class, so if it will not be invoked if the class is private or package private, and you are certain that its equals method will never be invoked. That was a confusing way for me to put it, but you get the point. And then he states, if you're extremely risk averse, you can override the equals method to ensure that it isn't invoked accidentally. And I think it's good to be risk averse in that sense, and I shall show the demo as to why it's probably a good idea to override the equals method, regardless of it being private, regardless of the class being private or package private in this demo. So we have this class called demo, and then in that class we have a private inner class. So a private inner class, now this class would only be used by the demo class because it's private. No one outside can use it. It's well encapsulated. And in the private inner class, we have overridden the equals method. And I shall show this bit a bit later. This is how you be fully risk averse and prevent any class from overriding the equals method or any user of this API. So if you go to the this private inner class method, which I know can be a bit confusing. I call it a private inner class method not because it's inside the private inner class, but this method, which is a public method, can be used to access this private inner class via the outer demo class. So that's what we're doing here. We're creating a new object of the inner class, and we're calling this function called display. And then we have perhaps a malicious actor who's trying to do the same thing, access that private inner class via the outer demo class, and trying to invoke the equals method. So if I do run this code, so here's a client that's using it. We've created an object of type demo, a new instance of demo class. And if I run this, you'll see, as expected, it's running the private inner class method, and it's first printing this log here. And then it's also printing the log inside the method display, which is inside, of the method display, which is inside the inner class, the private inner class. And that's fine. That's okay. We probably expect that. However, let's say this person wants to access, what did I do there? I collapsed my function. Okay, let's say this person wants to access the equals method that's in the private inner class, and we don't want it to be accessed by anyone. In that case, what we can do is we can throw a new assertion error saying, keep away. And therefore, if a client now tries to access the equals method via the outer class, it'll throw an error. Just like that. Throw an assertion error saying, keep away. And that's how you be extra punctilious and careful and not allow anyone to use the equals method, especially if that's not what's expected by the designer. That is the end of item 10, part 1. I was going to say at the end of item 10. Most certainly not. We've still got heaps to cover. In fact, part 2 of this item is going to be quite long because we need to go through all the reasons when it is appropriate to override the equals method. And that's quite interesting. So, and then in part 3, we'll finish it off with kind of summarizing on how to respect and obey the general contract when overriding the equals method. And again, I know it's quite long, but there's a reason that I'm doing that. As I said, the intent of these items is to go as deep as possible within what I can manage. And I hope you find value in it, because what's the use of just superficially reading these things if we don't really grok the concepts? Saying all that, thank you for watching. I hope you found value in this video. I shall see you in the next one. Cheers.